Hello, everybody. My name is Ilya Kaysen. I'm an engineering manager with Fluke Networks. What I'm going to try to do in this demo is to show you how the updated Survey Pro can help visualizing some of those important metrics about 802.11ac, and hopefully how the tool can help you answer some of the questions that John has presented in his slides. We'll start with launching, and one more thing, most of you are familiar with Survey Pro. However, for the internet audience, I'll be a little bit more verbose. So I'm starting my Survey Pro. And the first thing you can see here is that we're supporting the new adapter. And the demo that I'm going to do today is going to be performed using this adapter, which is a Netgear A6200 802.11ac adapter. I'm going to select it. And as John said, we have a couple of laptops in the back of the room set up with the same adapter and set up with clean floor map for this floor that you can, if you decide so, actually try to do the passive survey at the end of this demo. So I'm going to start with the data we've collected ahead of time, just to show you a couple of the ways we have updated the product, and we can visualize the 802.11ac specific metrics. I'm going to start with passive survey. And this is an actual survey performed using this actual 802.11ac adapter. But it was performed in Fluke Networks' Colorado Springs office. And the reason we chose this one to be presented in here is because the wireless environment over there is a little bit more sane and a little bit more typical of our typical enterprise customer. So right off the bat, since we're interested in 802.11ac, I'm going to disable 2.4 and a couple of other channels. And just to introduce the environment over there, we have two 802.11ac access points. And I'm going to actually drag them over because I happen to know where they are located. And place them on the map as a point of reference. Okay. First thing you will see right off the bat is the new way we present the information on the left-hand side filter about 802.11ac access points. So we show the wide channel capability of the access point. This access point is capable of 80 megahertz. It's centered on primary channel 36, and the full range is 36 through 48. So when you see this in the new product, that's a new notation showing that we're talking about 802.11ac access point. If we look at the properties of this access point, you'll see all those new things that you haven't seen before. So it's 802.11ac access point. It's 80 megahertz capable. It's the only mode supported, right? The open mode, there's no more greenfield, there's no more legacy, there's no more mixed. There's always mixed, very high throughput. And the access point is capable of 5 data rate upwards of 1200 Mbps. To interfere with the picture here a little bit, we also have a couple of legacy access points. So we have what looks like a Cisco 802.11a access point, and actually there are two Cisco access points, and based on the heat map, I think this one is located somewhere in the lobby here, and another one is located somewhere here. Okay. So, as with typical survey product, you see all of those heat maps available as a result of passive survey. And I'm going to take you through a couple of them. So our two 802.11ac access points are located up north here. And the signal strength pattern confirms that, right? We have stronger signal towards the top portion of the screen, and we have signal diminishing as we go down. By the way, in the tooltip, you'll have the same exact notation for 802.11ac access points with primary channel total capability, and once we have 160 megahertz capable access points, the tool is ready to reflect that as well, and the full range of channels. The next heat map I'd like to show you is there was some discussion about channel interference, how useful it is, can we trust the data? But I'm still gonna open it and show you. So if you believe it, this heat map somewhat confirms the fact that yes, we have two wider channel access points located up north. It is higher interference index in this area. As you go down, you have more narrower channels, and you have less interference on this scale. We used to have this set of heat maps separated in a separate section. MCS Index, TX, and RX. And we separated N from a C, and the reason is very simple. As you know, a C standard has defined a new range of MCS indices. N had, I think it was 30-ish, right? 32, 27. Forgot. But for AC, they define 9 distinct MCS indices, and this legend here shows the 9, and when you hover your mouse over it, it will show what it means, what's the definition of MCS Index 9 is. In this particular case, it's 256 QAM 5/6. And as you can see, both of our access points, they have fairly strong signal throughout the building, and both of them are capable of MCS index of 9. I'm going to skip the new heat map channel overlap for now. I'm going to go into AP operating mode. This picture is highly influenced by legacy 2.4 gigahertz access point. So I'm going to disable it. And this helps the picture a little bit. So as you can see, we have mixed, very high throughput access points dominating the north of the map. And as you go south, those legacy A access points that I mentioned, the Cisco access points, they are overtaking with their signal being stronger
this map really looks
towards the south.
The channel width map, right? So you can see it really doesn't mirror exactly, but it has very close coverage with where the channel width is.
Well, we haven't seen the channel width yet. That's going to be the next one. Right, so as John said, if we go and have a look at the channel width map and disable 2.4, it's going to be very similar. We're going to have.
And what's key, especially when we get into our rate heat map, is to see that up here in the north, in this area is where we're getting our good 11AC coverage, our good 80 megahertz channel coverage. Down here, we have our strongest access points, our legacy 20 megahertz channel coverage, and that may end up having an impact on our performance.
Can you select rate? Can we see the rates? The phi rates?
Yes. Yeah, you want to do the predictive phi rate? The heat map, Ilya.
Okay, do the
Predictive
drop
phi rates.
The
Yes.
the drop down heat map.
I will do that. I wanted to expand it here and just to show that two of our access points are here, right? And the never mind. Predictive phi right down. Yes. So this picture also confirms the same, which is up north we have our AC access points being the strongest. And let me disable 2.4 again. Up north we have our AC access points as being the strongest, capable of very high phi data rates. And the tooltip will show you. We're talking about 646.
Can you go to File Config and can you set that phi, that predicted data rate to dB conversion like you used to be able to?
Config.
To dB conversion? Oh, no, it's not supported yet.
So you can adjust them.
Yeah, it's not supported yet.
One suggestion would be, rather than adjust, you have one set for like Vocera, you click it and then it hides everything. I would love to have not just Vocera, but Cisco, Ascom, SpectraLink, any device that has specs, have you just put them in rather than we have to copy them all over from every device.
Okay.
Okay.
Down to the granularity of each USB adapter you've tested, you know them, stick them in there.
Yeah.
So I intentionally skipped the new heat map that we have developed that very specific to 802.11ac is the channel overlap. And that's the heat map, and that matches the screenshot that John had. And the way John explained this heat map is, can we fall back to 20 versus 40 megahertz channel in case we have an interference. So I think that's a very good description. What I would say is green would mean you have at least 40 megahertz wide channel to fall back to in case you have an interference. And if you hover over the green area, that's exactly what you'll see here. So the section title is, say, overlap channel with 40 megahertz spacing. Well, that's exactly what you will see. You will see.
You have 153 as your primary, and it uses 149 to 161. You do have overlapping here, 157, 161 overlaps on the secondary channels. So this would actually fall back to 149, 153, which would be its 40 megahertz fallback. So you could still transmit at 40 meg. Want a tooltip over the yellow? Here in the yellow, your primary is on 36. You have an interferer on the secondary of 40. And so the fallback here would have to be to channel 36 or 20 megahertz channel.
Right. And for the red, you'll see, for example, if you look at the very top section, you'll see that there's an Aruba access point that's exactly on the same primary channel as our AC access point. So that's your very direct visualization of the action you need to take, which is probably want to switch off that Aruba, turn it down, change channel, or do something about the interference. So somebody in the audience asked a question, okay, how do I know that the survey I'm doing with a particular adapter is going to be representative of the actual user experience. Well, this is a question to be asked even before that. It's clear by looking at this map that you have a very high potential for bad interference. So looking at this red, you can, it's very actionable information that you need to go in and do something about that bad overlap on the primary channel.
Do you want to do a tooltip, like you just did a second ago, just overlay? I would suggest we know what we're doing here, and it takes a bit to decode what that says and then to figure out which one's overlapping not. Yes. What if you added a graphic to there to actually show an 80, a 40, and then two reds, so you could highlight it for non-technical users? Very good idea. Kind of like you have I call it the manager button. You have a percent versus dB. Yeah. So you can go to percent so you can show your boss. It would be nice to be able to have something simpler like that.
Yeah, that's a great input.
That's a great idea.
I agree that we'll work on.
It's going to be actually very similar to one of the slides that John had with how the primary versus primary compare, right?
But yeah, I agree. So we can we'll work on making that a little bit clearer to really interpret what that means.
And you have the heights of the dBs as well, so they would actually be scaled to see how bad it might be red, but it's a little red.
Yeah, to make it more of a variable heat map like the others. Good point.
You know, I guess, 802.11ac, as it starts to evolve, the design process will follow. At Cisco Live, Cisco mentioned about looking at the 80 megahertz channel and overlapping the 40 megahertz. So any idea on how that's going to impact interference then? Right, because today we look at 1, 6, and 11, proper separation, right?
Right.
Whereas now if you take two bonded channels and overlap them by 40, what does that kind of look like?
Really, this is about validating your channel assignment plan. So that goes into play. How are you going to assign channels 40 mega? Are you going to 40 and 80 mega? Are you going to overlap them? This is really about validating it. So if you're going to do that, first of all, you want to make sure your primary channels are different so that they can transmit simultaneously. And this is what will validate that for you. This will show you where those overlaps occurred. And if you are intentionally putting a 40 with an 80, this will show you that. But it will also show you how much it's overlapping. And as Keith suggested, maybe we can vary the color here to show how much those interference levels are, very similar to the channel interference map. And then it will show you where you have your primary versus your secondary.
I was thinking not on the heat map, but in the little tool right there.
Oh, and the tooltip, and just showing
because it'd be tough to show that graphically. Yeah. But at any one point, you could catch a piece of data.
But the idea is very correct. I mean, we specifically wanted to design this particular heat map to be very direct and very actionable. So, for example, in some of our other heat maps, we would show a lot of information about all the data points we have for this XY. In this particular case, we're very specific about the tooltip, saying that's why we colored something green versus yellow versus red. It's the explanation of why, what you see is actually of the color it's supposed to be, kind of backing up and helping you trust the information.
So that we have time for the test drive, you want to go ahead into the IPerf surveys?
Yes, real quick, active IPerf. I'm going to skip the one we did with Proxim, which is N, just to compare how N rates are slower than AC. I'm going to go straight into here. And obviously we don't have channel overlap, but what we have is our old friend signal strength. Interesting artifact over here. Is that the correct project? Yes. Okay. So this is the main reason why we rushed into supporting native non-promiscuous version of the of a couple of the leading adapters, and we didn't wait for AirMagnet's typical approach of developing its own driver. Active IPerf is as close as you can get to measuring the actual performance experience that users will have in a particular environment. And this is the actual heat map of the actual IPerf performed in that Colorado Springs office. And for example, one interesting thing we saw is that the throughput down was higher, and closer to the access point location, it was approaching some really nice, interesting rates.
This is where we had the wider channel coverage.
Right. And for the up, the pattern is similar. However, the actual rates are, 150 Mbps lower on average. And this research was also the basis for what this testing that we've done was the basis for a couple of slides that John has presented earlier with a bar chart showing different adapters. Go ahead, Kit.
You don't flip back the previous one? So you're saying the download was much higher than the upload?
Yes.
We found with N is, and even using the Air Magnet N tool, simulation tool, up is normally faster than down because your APs have more capabilities than your clients do. So they listen better. So I just thought this is kind of backwards data.
Well, we used high-end laptops. We had USB 3.0 with faster rates. And yes, that's...
Even when we did, that first chart I showed showing the comparison between two adapters, that was not, that bar chart, that was not done within survey. That was just a strictly IPerf running on a PC. And we actually saw higher rates on the downlink because we did simultaneous IPerf up and down, and the down rates were higher than the up rates in that particular one.
Yeah, I have to agree with Keith. My testing showed the same.
Yeah, this is upside down.
Backwards, yeah.
Yeah. I just have a question about...
For AC
For AC specifically.
Yeah.
I just have a question about how you're doing the IPerf test, just so I know how it's being done. Is this a continuous IPerf test while you're walking around, or is it spot checks with a complete run of IPerf, then you're moving and mapping?
No, it's a continuous test.
And then my second question is, performance is good, and forgive me, I've never actually touched this product before. Is there a spot that you map out latency as well, or is it you can just map out performance?
No, it's strictly throughput.
Okay.
I think if you're going through the efforts of doing that active IPerf and continually running it, one of the things that I think would be interesting to try to add is kind of something like what VeraWave did with their product testing, where you can start to actually see like roaming. I was on this AP, start to fill that void that is being left by Ixia at the moment until they get their acts together and recycle that product. If you're having the data because you have a client that's always being connected and
so
you're
show
getting
the
that
roaming
data,
zones where it's
exactly
switched
to be able
off
to
in
see,
here.
okay, this AP was on this one. It just makes it gives us more data and more reasons to use the tool and just stick to a single tool instead of having to, okay, I did my survey, all right, now I'm going to launch this tool and walk around and interrupt you all again, especially if we're in a hospital environment. We know that we can only get one pass at a room sometimes.
Right. No, that's good. That's a good point.
Notice that's only on one AP.
Do that.
It never roamed the whole time.
Yeah.
Just maybe real quick. This is the up and down rates in much lower range of the spectrum of the legend that we did with N card. So exactly same survey path, exactly against the same IPerf server, exactly against the same AC access points, but using the Proxyman card, just for kicks.
Could you do a diff view between those two?
I cannot. No, not yet. To be supported.
Okay.
Now, when you said IPerf down, up, down being from the access point to the client, up being from the client to the access point.
Okay. Again, that concludes the demo section of our presentation. Next thing is...
I wanted to maybe show them the diff view quick.
The diff view?
Yeah.
Oh, he said it's not in this current rev, so. I just think that would be a nice, you could show, this is what you have today, this is what you're going to have in the future.
Well, we have, we do have one diff view that we did that compares what your IPerf throughput is with your phi rate down.
Well,
which
what I can do is a diff view of
that would be with the active IPerf.
between active and predictive from the passive. I can do that.
Yeah.
So the diff view I can do today is if we select the active IPerf using Netgear, and we're going to select throughput down. And for the second survey, I'm going to select the passive. And this is another change that we made. We used to be able to compare apples to apples. Obviously, for passive, you don't have IPerf throughput metric, but instead you can select predictive.
Love it.
And what's interesting about this is, everyone knows your user throughput's never going to match your phi rates. But I've read papers saying, assume a MAC efficiency of 70%, multiply your phi data rate by 70%, that's your user throughput. That's not going to be the case. You have beam steering, you have other clients utilizing the network, you have A and N clients slowing the network down. Phi rate is not an accurate indicator. So even when you have of user throughput, so even when you have consistent phi rate throughout, your user throughput, even as a percentage of phi rate, is going to vary greatly. So phi rate is an important contributing factor to survey to see where you're getting those higher AC rates at. But it will not tell you exactly what your end user throughput is going to be in that area. In some cases, you may have several hundred. Some cases, you may have 10 or 20.
But what this shows is at distance, it's more accurate than it is up close.
Yeah.
So at distance, the phi rate's a pretty good predictor of what your throughput's going to be. But within that 2256 QAM is where it's going to be highly variable. So I love this. Is fantastic.
Okay, so that wraps up our CAN demo.
I got one last question.
Sure, like.
And delete, please don't throw me in the dumpster after I make this comment. Features are great. We need more new features and be able to enhance and be able to do our jobs, but can we get an updated UI that's not so convoluted and inefficient from workflow processes? And the second thing is, what about stability? Are we, stability. Too much RF.
Stability.
Yeah, no, dang it, knock it out. No, because I know at one point in time we had heard about a possible recode happening to be able to get this to be running more efficiently and being able to better utilize the RAM in our machines. Because it's large files is the big deal.
I'll take the first one, and that is, So actually, we'd love to get more input from you all on what would be good workflows that we could put into this.
Well,
this release.
What Chris has there in iCarry too is that Surface Pro. We need things that are, when we're trying to use a pen input or our finger input on tablets, in convertible tablets as well, not just meaning an actual full-fledged tablet.
Yeah.
It's really hard to hit all the tiny little check boxes and radial buttons and
resize when you make
Yeah. So it's very important for us to get this release out very quickly because 11AC is. But as we discussed before, this isn't going to be the end of it. We're working on other releases coming out after it. And I think for the next one, when we're really looking at adding a lot more capabilities for 11AC and for other things, we can look at, really adapting this for new use models. And at the same time, we are looking at the new trends that technicians have and going more towards tablets and phones and making sure our portfolio adapts as well. There's obviously some very interesting challenges with doing deep embedded Wi-Fi analysis metrics like we do and doing it on tablets and phones and even iPads and iPhones. And so
AirMapper is a completely different topic. I mean, you've heard my feedback. Yeah. I know you have from because I remember talking to you at Cisco and you're like, oh, you're him, huh? But I'm talking more for when you're just still on your actual Windows machine and not so much the portable mobile devices, but just a laptop tablet based. I always use Lenovo's for my surveys, and even on that with the pen input, it's really hard. And just there's slow transitions between items that you're doing, and it's not as efficient as some of your competitor products are from when you're in a consultancy agency. The quicker you can turn your data around, the quicker.
We will have some. We are having some new stuff coming out soon that I think I'm very curious to have you get your hands on and take a look at.
And then we do recognize the computing platform shifts that's happening in the industry.
Obviously, if you look at what analysts are saying that at some point of time PCs will disappear, how true it is, I think we can all bet on it if we want. I don't know if some will win, some will lose, right? So we recognize that shift. It's going to happen at some point of time. So that's why AirMapper was our first attempt to introduce solutions on that smart device platform, right? So as we move along, right, usability has been very important, is very important, especially as we get into industries and verticals and organizations, right, with the economic situations, right? People are wearing multiple hats. People don't have time to do stuff, right? People don't have time to deal with the complexity, right? So we do recognize that fact as to the easier we make, the better it is for the customer, and at the end, it's going to be better for us. So that's the direction we've been trying to take. If I go back to the other question, right, on the stability, right? So again, we've had some challenges, to be honest with everybody. In the past, last year, we put in a lot of effort. So that's why you may have seen there were no major releases from Air Magnet last year, right? And people may say, oh, how come Air Magnet's not introducing something new? Air Magnet's not innovating. We went back to the drawing board and we said, the most important thing is to fix the stability challenges that we may have in certain situations, right? Obviously, networks are getting bigger, networks are getting more complicated, number of APs, right? Now you just see thousands of APs, especially when you do an outdoor survey or whatever, right? So we recognize some of those issues. We put in a lot of effort into fixing the majority of them last year. And that's where I think we've overcome that hump. Obviously, as with any software product, right? And again, if you look at Microsoft or anybody, right? I think the more successful you are, the more people that use your product, everybody uses it differently. So that opens up lots of challenges. So we try our level best to keep up with those scenarios or the challenges as such.